Today, we're going to be looking at a really fascinating new take on network security called DPZTN. Think of it as a blueprint for a smarter, self-defending internet, one that's built for a future that is way more connected and honestly a lot more dangerous than anything we've seen before.
So let's just jump right in with a question that pretty much flips cybersecurity on its head. What if your network didn't have an inside? I mean, for decades, we've been building these digital fortresses, right? But what happens when the bad guys are already inside the walls? This isn't just a hypothetical. This is the new reality we have to build for. Because, let's be real, our digital walls are crumbling. With the explosion of things like 6G and the Internet of Things, where everything from your car to your fridge is online, that old castle and moat security model is just, well, it's becoming useless. The border we were supposed to be defending, it's pretty much vanished.
And this table here really shows you that massive shift in thinking. We're moving away from just focusing on external defense, where we kind of just assumed that once you were inside, you were safe. In this new reality, there are no trusted zones. The big assumption now is that a breach isn't a matter of if, but when. So security has to be smart, adaptive, and work from the inside out.
Okay, so how in the world do you protect a network that has no walls? Well, you need a totally new philosophy. And that's where the Zero Trust Rulebook comes in. It's a security model literally built for this new chaotic era. So here's the core idea, the absolute heart of it all. Zero Trust runs on the simple but super powerful mantra of never trust, always verify. It seriously doesn't matter if you're logging in from the head office or a random coffee shop. The system treats every single request for access as a potential threat that has to be proven safe.
And this whole philosophy really boils down to three core rules. First, assume hostility. Just act like the attackers are already inside your network. Second, verify explicitly. Don't just trust a password. Use every bit of data you can to confirm who someone is. And third, and this one is so important, grant least privilege. Basically, give people access only to the exact things they need to do their job, and absolutely nothing more.
Okay, so that's the theory, but what does it look like in the real world? Well, this brings us to what our source material is all about, a powerful new architecture called DPZTN. Think of it as the ultimate smart, dynamic network security guard. So what makes this DPZTN thing such a big deal? Well, for starters, unlike a lot of other models, it's truly distributed, which just means there's no single point of failure an attacker can target. It's also dynamically adaptable, so it can literally change the security rules on the fly. And this is critical. It builds security functions right into the network itself, making everything faster and way more responsive. DPZTN really stands on three powerful pillars of technology. First, it uses blockchain to create identities that are decentralized and basically impossible to tamper with. Second, it uses smart contracts to enforce security policies that can change in a split second. And third, it uses these cool programmable network switches to watch traffic as it's happening, not after the damage is done. Okay, so we know the parts, but how do they all work together to create this super intelligent security engine? Let's pop the hood and take a look. When you first try to get on this network, the whole process is incredibly secure. Your identity gets registered on the blockchain, which creates a unique ID that can't be faked. Then, the network security checkpoint authenticates you. But here's the kicker. You're only given the absolute bare minimum access to start with. On this network, trust has to be earned. So how do you earn that trust? Well, the system is constantly calculating what's called a dynamic behavior score for you. It's kind of like a credit score, but for how you act on the network. This score is managed by a really clever algorithm, you could call it the system's brain, that is always watching and evaluating your behavior. So what's a good score look like? A normal, trustworthy user just doing their thing will have a score right around 0.8. The system sees that, thinks you're healthy, and lets you do what you need to do. But, and this is key, that score isn't set in stone. It's being updated with every single action you take. And this is where it gets really, really cool. How does this system actually handle being attacked? Let's walk through the experiments from the research paper and see what happens when DPZTN is put under pressure.
All right, so in the experiment, they have a malicious user who's already on the network, and this user launches a classic DDoS attack, trying to flood the system with junk traffic to shut it down. The system's reaction is instant. The algorithm spots this weird, aggressive behavior, and the attacker's behavior score just plummets. It goes from a healthy 0.8 all the way down to 0.197. That massive drop is basically a giant red alarm bell going off inside the system.
And because that score fell below the critical line, the system doesn't wait around for a human to do something. It automatically, in real time, just revokes the user's access. Boom. Access denied. The attack gets shut down before it can do any real damage. It's all automated, intelligent, and unbelievably fast.
But you might be wondering, can it actually handle this at a large scale? And the data says, yup. Even with 10,000 people using the network at the same time, the system's CPU usage stays around 70%, and memory is at 60%. This tells us that DPZTN isn't just smart, it's also efficient enough to protect huge, complicated networks without slowing to a crawl. So what's the big picture here? This is way more than just a cool research project. This technology has some really profound implications for how we're going to secure our future, which, as we know, is only getting more and more connected. What this really means for all of us is safer smart homes, safer self-driving cars, and even safer smart cities. It means we can build a much more resilient backbone for the 6G networks that are coming. Ultimately, it's a promise to shift away from just playing defense and toward having an automated, intelligent security system that's proactively hunting for threats and adapting in a heartbeat. The researchers who created DPZTN said it perfectly. This is a huge shift towards something they call endogenous security enforcement. Now, that's just a fancy way of saying security that comes from within the network itself. It's security that's baked into its DNA, not just some wall you build around it. Which kind of leaves us with one last big question to think about. As all of our technology starts moving towards this zero trust model, it forces us to rethink what trust even means. In a world that's built on constant verification, maybe the answer is you don't trust anyone, you trust the system.